In part A of problem number 1, you have to use StatKey to find the equation of a regression line. Typically, if you're going to use StatKey for that purpose, the one thing that you have to watch out for is making sure you have the order of the variables correct. I don't think that'll be an issue here, since in the table they're labeled as X and Y, and that's enough to dictate the order. Part A is worth 1.5 points, where it's half of a point for the edit data window, half of a point for the summary statistics box, and half of a point for having the equation of the regression line written correctly, and that includes having a hat over the Y. Don't forget about that. It's really easy to forget that hat, but that needs to be there. This is what the two screenshots look like that you need for 1A. The one on the left, the edit data box, that's visible after you click on edit data, and then the summary statistics box is generally on the right side of the screen. The edit data box, the reason I need that one is because that effectively acts as insurance against incorrect data entry, so just in case you make a mistake in entering the numbers. And then the summary statistics box I need because the slope and intercept are there. If part A is worth 1.5 points, parts B and C are worth half of a point each. Both of those are pretty quick if you already have part A done. Part B, using the equation of the regression line for prediction, effectively that's just algebra. If you already have the equation of the regression line, it's 2 algebraic steps. And then part C, if you already have part B done, is 1 algebraic step, so that one's really fast. Just make sure you get the order right in part C. Problem number 2 involves a regression model used to predict the population of cities in Kentucky from their area in square miles. The first two things that you have to do, interpreting the slope and interpreting the intercept using the context of the problem, those are worth 2 points each, and there's a specific reference that you want from my section 2.6 notes. It's in the second half of the video, probably not too deep into the second half. The thing that you want is the part about how to interpret the slope and intercept. There's one slide where it has general interpretations, and then the next slide has specific ones for the cricket chirps and temperature example. I would say use those example ones as templates. If you follow along with what's there in that example, you're going to get all of the pieces that you have to have. So the slope, if that's worth 2 points, it's half a point for saying something about x increasing by 1, half a point for the change in y that's specified by the slope, half a point for saying that it's a predicted change in y, and half a point for the context. Part B, the interpretation of the intercept, is a similar thing, 2 points, and there are 4 pieces worth half of a point each. Half a point for something about x being equal to 0, half a point for the specific value of the intercept, half a point for stating that that's a predicted value, and half a point for the context. Parts C and D are worth 1 point each. Part C, by itself, is the intercept meaningful and why or why not? Think about it this way. The x variable is area, so when you're talking about the intercept, you're talking about a scenario where the area is 0. If you're looking at the intercept in isolation, that's what you're talking about. But if the area is 0, how many people can you fit into an area of 0? Does that predicted value actually have any meaning there? Another way to think about this is, does it make sense to have a city with no area? I'm kind of telegraphing the first part of part C, but I think that's okay. And I think based on what was just there, you can formulate the second part without too much trouble. Part D, is it reasonable to use this model to predict the population of Lexington and why or why not? The thing that you want to use as a reference is in my section 2.6 notes. It's toward the back end. It's under the part about regression cautions. So it's at the very end of the section 2.6 notes. This is why the data table is there. Because in parts A, B, and C, you don't need the data table at all. You don't need to use it extensively in D, but you need to use it as a reference point. And of the things that are there in parentheses where the area and population of Lexington are listed, one you need and the other one is not going to be relevant to getting the right answer. But the thing that you want to reference here is one of those things under the heading of regression cautions at the end of the section 2.6 notes. Problem number 3, we have some software output for a regression model where the turbidity or cloudiness of water in a river is being estimated using a regression model where concentration of suspended solids is the explanatory variable. The first thing in part A is to write out the equation of the regression line. That's worth 1.5 points. It's half a point for having the correct value for the slope, half a point for having the correct value for the intercept, and half a point for having a hat over the y. Part B, the p-value, that's worth half of a point because there really isn't any work to do there. It's just pulling the correct value out of the table. Part C, a formal conclusion of the test using the context of the problem. There's a reference for this toward the end of the section 7.1/9.1 notes. In the video, it's at the very, very end. It's the second to last slide. Basically, there are two possible answers here. Either there is enough evidence to conclude that there is a linear association between suspended solids concentration and turbidity, or there is not enough evidence to conclude that there is a linear association between suspended solids concentration and turbidity. It's one of those two things, and it's entirely going to hinge on the p-value. D, finding a 95% confidence interval for the slope. Part D is worth 2.5 points, 1 point for the critical value, half a point for the correct degrees of freedom, and then half a point for the correct percentile/proportion in the central region of the curve. If there's anything worth saying there, I think it might be just watch out with the degrees of freedom. Just be careful with that, because it's slightly different than what it usually is. For the other 1.5 points, it would be half a point for having the correct point estimate, half a point for having the correct standard error, and then half a point for the simplification/algebra. Part E, about blank percent of the variability in blank is accounted for by the linear regression model. There's a thing that would be a great reference for this. It's in the section 2.6 notes. It's right after the interpretations of the slope and intercept. It's the thing that's immediately after that. It's not in section 2.6 in our textbook. It's later in the book. It's in chapter 7 or chapter 9, depending on if you have the ebook or the hardcover version of the book. But that's where it is in my notes. That's where you want to look. There's a thing that looks exactly like that sentence. So you just have to take that and just stick in the appropriate values from what's there in this problem, and you'll get part E. And part E is worth 1 point, so it's half a point for each blank.